Cool. Okay, so welcome grade 11s. You'll notice my lovely Math 24 explanation block. I hope you enjoy it. It was courtesy of our last lesson. And yeah, just a huge welcome to everyone. I really want you guys to give the Math 24 question a go, so you work on your mental maths to start today. And then, yeah, tell us what you've been up to. What's going on in your, have you started exams, or how are things going for you at the moment? And a big welcome to you, Linda, who has just hopped across from the grade 8s in record time.
Hello, guys. Hello, everybody. How's my favorite class doing?
There we go. I think everyone's still finding their bearings, eh?
Yeah. Oh, I hope it went well. Rua wrote his maths tests on Monday.
Rua had a tough. Is that a, yeah, are those tears of joy, Rua? I suspect not. Nate says exams are next week for him, so that's still coming.
All the best, Nate.
Okay. So, Sarah, you're on form as always. We'll wait a bit longer before we disclose whether or not things are true or not, but Sarah's writing next week and Rachel is writing her exam on the 6th, so next Monday. Cool. We're going to get you ready, Rachel, and I'm going to tell you about some other resources that are still available from Watobe that not everybody knows about in this lesson. So yeah, I'll talk about that shortly. So welcome to Dawn, welcome to Anele, welcome to Nomhle and Joel. Welcome to everyone. The class is getting big, but it still feels kind of like we sort of know everyone, which is great. But I definitely noticed the Zoom scrolling list is getting longer.
It does.
It's like I see some names at the beginning and then I'm like, oh, this, and then everyone just pops up at different times.
All the best, all of you who are writing exams.
Thank you.
All right, so today, let me write in what lesson. So this is lesson 4 of 4 on number patterns. And so this is our last lesson on number patterns. And I think we've made really good progress. Candy says she's writing paper 2 on the 9th. So you've still got a bit of time, Candy, which is fantastic. Okay, just about ready to get going. Has anybody else, I see Sarah has proposed some solutions. Joel has proposed some solutions. Anybody else want to let us know if they can get the blue or yellow cards? If you're not sure what we're doing with these number cards, have a look. I have a lovely explanation block for Math 24, which will now be part of our startup screen. So let's have a look. Joel said 5 times 8 is 40, and then 40 plus 8 is 48, and then we have 48 divided by 2, which is 24. So you have got the yellow one.
That was awesome. Well done.
Yeah. And then another way of doing the yellow one is proposed by Sarah, who said, I also will go 5 times 8 is 40, but then what I'm going to do is I'm going to say 8 times 2 is 16, and then I'm going to subtract 40 from 16, which gives me 24, which is another way of doing the second card. Okay, so what I wanted to suggest is, if you can in future, because I know some students only get in literally as the clock strikes 6, if you want to practice your Math 24 and feel a little bit less under time pressure, can I suggest that you come to class from 5 to 6? Because it'll allow you a bit more time to just think through. A lot of the time, students who are suggesting these answers have had a bit more time to think about these. Okay, that was great. And also, I sort of point out that every lesson, the Math 24 explanation block will be here. And if you have a cool strategy that you think should be in the block, then definitely let us know, because that helped us a lot in the last lesson. Muzi has said for the blue one, I'll pop this answer in, 5 minus 2 is 3, and 6 plus 2 is 8. And so then 3 times 8 is 24. Well done, Muzi. That was fantastic. Now I can start my lesson knowing we've solved the Math 24 questions. Cool. So then, I don't know, the admin and announcements. Yolanda, if you want to just tell the students about this main announcement to start off with.
Oh, yes, guys. Welcome to everybody and everyone who's new. So I have good news. During the holidays, we actually do have classes. So if I'm not mistaken, Teacher Peter, is the same day, same time, everything hasn't changed. It's just that we will have those classes during the holidays. And it's the most important thing because it's after your exams, and also you can ask like a lot of questions about what was difficult in your exams. So guys, it's very, very important for you to attend, okay? So I hope to see you there because I'll be here. I'll be.
Thanks, Yolanda.
And it's a quiz day.
Yes. And so the other thing to remember today is that, yeah, at the end of the lesson, we're going to do a little quiz just to kind of check your understanding of the work we've been doing. And yeah, well, the reason we're telling you about this is a lot of students have been asking us, do we continue in the holidays? And so the resounding answer is yes, we do. Every Monday, every Wednesday, Watobe will be 6 o'clock. We'll be doing grade 11 maths. And so we want you to, just to know that that's happening. The other thing is with so many students going into exams, I often get asked, can you help us with this topic? Can you help us with that topic? Now, in the actual lesson today, we've got a topic called quadratic patterns we're doing, but we've been doing this a while now. So if you go to the website and you go to classes, I've taken some screenshots, and then you go to grades, click on grade 11, you will see a whole bunch of recordings from earlier topics. And if you need to, you can even go back to earlier grades like grade 10. And so, for example, if you're like, oh, I need some help with circle geometry, well, we did loads of lessons on that earlier in the year. And so I just want to make sure all students are aware of that. Okay, awesome. Okay, anything else, Yolanda, before we get going?
Other than that, I'm good on my side. I'm good, guys. I'm good. I just have some, I just hope that you're sitting, at the table with a pen. It's cold, guys. Just grab blankets, but make sure you sit at the table with a paper and let's enjoy the ride. It's good for exams because are coming up. It will be a good revision. So let's do that, guys. So whenever you sit down to work with Watobe, always make sure your learning environment is prepped, right? So you have a table, you have a book, you have a pen. We don't want you to be sitting and just watching. We want you to be actively participating. We know that you will learn better if you do that. So please, make sure you're sorted like that. Okay, on to the lesson. So in the last lesson, we were doing some questions like this, and I just want to make sure that everybody is able to do them. So let's start with this question. I want you're given a quadratic pattern, and you need to find for me the values of A, B, and C. And in previous lessons, if you're completely new, you might need a bit of help. But we discovered that because of the structure of quadratic patterns, certain things will always be true for a quadratic pattern. We know that 2a will always be equal to something. We know that 3a plus b will always be equal to something. And we know a plus b plus c will always be equal to something. And so this is the structure that we use to help us find A, B, and C. But I want everyone to do it, and then I will get back to you in a minute or two. If you are new today and you want to have a little bit of a chat first, raise your hand and we will unmute you and we can discuss a little bit about this. Or maybe if you've just forgotten and it's been a busy week and you're like, oh my goodness, I know it was 2A, but I've forgotten something.
then raise your hand. Okay, so David has raised his hand. So let's go to David. Hi, David.
Oh, hi, sir. How you doing?
Very good. And you, David?
So what I wanted to ask is, when are we doing functions?
Function starts next week. Next week.
Oh.
So it's coming to a place near you. But there are some functions pre-recordings as well.
On YouTube, sir.
On the website and then ultimately on YouTube, yes.
Okay, thank you, sir.
Pleasure. Okay, form. So let's make sure that we know how to do this one. This is what we were practicing in the last lesson. And what I'm doing right now is I'm calculating what's called the first differences. So I went 4 minus 2 and I got 6, 16 minus 4 and I got 12. That's what we call the first difference of a pattern. And in a quadratic, we always expect the second difference to be constant. And to calculate the second difference, we subtract the first differences. And so good news for me is that the second difference is 6.
I see
So,
people are on fire.
Yeah, I feel like
question C.
I feel like this sort of question is like we've done this. They're ready to rock and roll. But let's just make sure we do it carefully. So then the second bit is I need to know what 3a. Well, first of all, I need to sub this in. So I go 2a is equal to 6, which then means if I divide both sides by 2, a should be equal to 3. Now, that's the first part. I've got the a, which is this one up here. But I need to find the b. And the way our method works, and again, if you're new today, you will have to look at the earlier video. We look at the first difference. And the very first difference is 6. And so I'm going to write a 6 here. But I have to do some manipulating because I have to put a 3 in for where a is. So there's an a in this question. And so if I put a 3 in there, I get 3 times 3, or I get 9 plus b is 6. Which then means if I take away 9 from both sides, I should get minus 3. So that is, and then the last thing that we do is we say that a plus b plus c is always equal to the first term. And so we say that that's equal to minus 2. We have values for a and b already. So we go 3 plus minus 3 plus c equals minus 2. And 3 plus minus 3 is nothing. And so c must be equal to minus 2. And so have I answered my question? Find the values of a, b, and c. A is 3, b is minus 3, c is minus 2. I went a bit quicker because of the practicing of that. Just tell me if it was too fast, give a thumbs down. If it was the pacing was right the way I did that, give a thumbs up. Because I'm going a bit quicker, assuming that you're getting more familiar with the method. Okay. So there are a few students who think it's a little bit quick. Okay. So yeah, we're roughly the right pace, but we need to slow down a little bit. Okay. Cool. So the main thing I want to point out to you guys is whenever you have a quadratic pattern, we always have to do this bit over here, what I call finding the second difference. And then you have to have the 3 steps, and you have to memorize these 3 steps and know what the things in blue that you're filling in. Okay. Let's do, actually, let's do a slightly different type of question. We did this in the last lesson as well. And in this case, you have to find the value of n such that Tn equals 298. Now, I'd love a student to, Anele, I will go through 3a plus b later in the lesson. I will go over that exactly from scratch in a later example, and I'll come back to it. But before I do that, would anybody like to explain the first step as we try and do this continuation from the last lesson? If you could raise your hand, I'd love to hear what the important thing I need to remember at the beginning of this type of question.
Be right back. Just a second.
Cool. So find the value of n such that when Tn is 298. So Dawn, we're definitely going to use the quadratic formula in this question, but I'm really interested in knowing what do I do? How do I use this 298? Like I know that, for example, I'm basically trying to figure out, is it T12? Is it T15? Is it the 17th term? Is it the 19th? How do I work that? I want to know what that first important step. I'd love a student to raise their hand and help me if someone is feeling brave enough to help us out. Okay, Nontokozo, tell me what the most important first step is. Yeah. Hi, Nontokozo.
Hi, sir.
What do I need to do to start?
Hi, sir.
Hello. Okay. Yes.
Hi.
I think Nontokozo, your audio is a bit. Okay, unfortunately, Nontokozo, your.
Yeah, we'll transpose this 298
Okay.
to the right.
Perfect. Okay. So what we're going to do is, Nontokozo is basically, and I see this in the chat as well, is you sub the 298 into this formula here. So basically you're saying, I know the final term is 298, and I'm going to sub it into that formula. Okay, from there, I then need to solve this equation. And in order to do that, I need to put it into standard form. Okay, good. So see if you can get the answer to that. I'll wait a little bit. I think I would be wanting to deal with this 298 first. If only I could get like a 0 on one side.
Let's go, guys. Let's do this.
So I think that would be a good first step. But now I still don't know what n is, and I'm trying to find n. So over to you guys to see, can you figure that out? I'll even write you a little friendly little formula sheet on the side while you're working it out. And this little triangle thing is called delta. Okay, let's see the chat. Remember, we're looking for an n value in the end. No worries, Nontokozo. So I see Nomple and Anele have answers coming through already. Let's just make sure we've got our working correct. So for me, if I go minus b plus the square root over 2 times 2. Okay, let's just see. We shouldn't be getting a square root. Maybe there's a mistake in the question. I get the square root of 2401 is 49. And so I'm taking the plus. So I'm not taking the negative because since we're solving for a positive n, it's unlikely to be helpful in this particular case. So I get down to that. See if we can get a final answer coming through. So what's minus 1 plus 49, guys? Be careful. What's minus 1 plus 49? I think that that is going to be 48 over 4, which gives me what value? It would give me, okay, it would give me 12. So let's just make sure we understand what we did there, because it was quite a lot of working. So in our journey, we were at the stage of basically over here. And when we got to this stage, it was a quadratic equation. And in order to solve the quadratic equation, we need to use the quadratic formula. Now, what I suggest to all my students is you break down this formula into steps. Now, some of you will be able to do it on your calculator straight away, and that's not wrong, but it often is good to work out delta in one step. So I got my delta value, which was this. Then I put my delta value into the quadratic formula. Now, you're quite correct to notice that suddenly there's no negative here anymore. But because I was solving for a positive n value, the n had to be like the number of in the list, or like the 12th term or the 15th term. I was ignoring the negative because I knew I couldn't have a negative final answer. And so I just went minus 1 plus the square root of 2401. I checked on my calculator, 2401 square root is 49. Then I had to watch out for a silly mistake. Negative 1 plus 49 is 48. And then I divided by 4, which means the final answer is that 298 is the 12th term in the list. Okay. So again, if there are any questions or comments, or if that felt good, give a thumbs up. I want to get a sense of what my pacing should be, because this is a typical exam question, right? So this is 5 to 6 marks in an exam. If you're unsure, I really do want to help you here and now, as opposed to just moving on. Okay. Cool.
In short, if you need to, while we edit.
Yeah. And Yolanda is also standing by, so please don't be afraid to ask some questions. Okay.
Yes, please. Yeah.
Okay, then I know earlier in the lesson I said I was going to go through the 3a plus b. I will, but I just want to do a different type of a question that is actually quite easy, but I just want to see that you can do this. So this is another type of exam question, and all it says is use the general term to generate the first 4 terms of the sequence. So what do? If I want the first 4 terms, all I'm going to do is use this formula to help me. So T1 is just going to be 1 squared plus 3 times 1 minus 1, which is 1 plus 3 gives me 4, minus 1 is 3. So guys, what I'm doing is I'm doing an example for you, and then you are going to do a one like this after I've done an example. But just for now, put your pens down and watch what I'm doing. In this question, it says use the general term to generate the first 4 terms. And this is the general term formula. all I'm doing is I'm subbing into that formula. So watch how the second one is a little bit different. Notice how there's a 2. I'm going to put a dot to mean times. I get that. So 2 squared is 4 plus 6. That's 10. So this will be 9. So far in my quadratic pattern, those would be the first 2 terms. Now, what's the third one? Well, the third one would be 3 squared plus 3 times 3 minus 1. This is going to be 9. So that's going to be 9. This is going to be 9. That's 18. So that's 17. And then the last one they've asked me to do is, how do I find my fourth term? Well, I make n 4. And if I put 4 into this formula, I get 4 squared plus 3 times 4 minus 1. And because I get that, so I get 27. So that is how you can use the general term formula to get the first 4 terms of the actual pattern. So that was my example. So what I want you to do now is I'm going to give you a similar question, and I want to see that you guys can carry this process out. So all I'm going to do, I'm actually going to bring this down here. I want you to do I want you to do the same thing for B and for C. And all I want you to do is I want you to work out the first 3 terms. I don't want the first 4. That's a bit much. So all I want you to do is work out the first 4 terms of each thing in yellow using that formula. And just make sure you can do it, because it's easy marks in the bag if you can. If you feel very comfortable with this, you don't need to do as much working as I've done. I'm simply doing the working to try and make it as clear as possible. Okay, so again, you're going to give me the first 3 terms of B, and I also want you to work out the first 3 terms of D. Over to you guys. Only the ones in yellow. So once you've done 2 of these, you've got it nailed. So
let's do this, guys. Bradley is already like, yeah, I'm our ancestor.
Yolanda, can you see that tricky negative in front? That might catch a few students.
Yes, it's a sneaky one, that one.
Yeah. I'm just going to take some insurance here. Okay. Yes. So just do it methodically. Watch out for the squares. The squares can be a little bit tricky sometimes. Okay, so for B, the answers, the first 3 terms are going to be -6, -9, -14. So that's for B. I want to see if students are able to get for D as well.
Guys, remember to do corrections like this. You can see your mistake and correct. And so just give yourself marks. It's, yeah, it makes me feel proud when I have a red pen tick. So I have more marks in the bag.
So it's funny, like simple substitution questions can really, you can get a lot of good marks, but you need to get your technique, nicely sorted. So T2, there's lots of twos going on in the second one. So I want to be careful that I don't make a silly mistake. So I get 4, so I get -8 plus 2 plus 1, which is going to give me -5. So we have 0 as my first term, -5 as my second term, and what do we get for the third one? What are you guys getting? I think I see the answer coming up. Okay. So -18 plus 3 is -15 plus 1 is -14. And so we should have, as our first 3 terms for D, we should have 0, -5, -14. And for B, it was -6, -9, -14. So again, whenever you are given a general term formula, you can work out the first 3 terms, you can work out the 50th term. All you need to do is substitute into that formula. Okay. Cool. So I'm going to move on to one more. Actually, I think it's time for our brain break. Let's have our brain break. So quickly, I want everybody to just stand up, and I want you to do a quick little stretch. I want you to choose the stretch that will be most useful for you today. So if you've been sitting down a lot, maybe stretch your legs. If you've been keeping your neck really stiff for a lot, stretch your neck. And I just want to see you on the cameras. I want to see you standing and just stretching out a little bit. Okay. Because we've been going for half an hour already, and research tells us that our brains don't learn as well if we've been, sitting in the same place for too long. And if we can get a bit of extra blood and oxygen going around, it'll be good for us.
Let's go, Nancy. Let's go, Zukanye. In the end, I see you. Guys, you need to stretch a little bit.
Just stretch. Stretch it out, guys. Stretch it out.
Well done, Rachel. Nice.
And then once you've got back from your stretch, so I'm standing up to do my stretch, I want you to apply your brain to the brain break. Can you find the value of a square? So in this question, what's the value of a square?
Did all of you now switch off your cameras? Now I can't see anyone.
Everyone's hiding.
Yeah. Oh, you guys.
Okay, so everybody seems to be, wow. Everyone's smashing this. So I can see everyone has said that a triangle is 3. And then you've said that a circle is 2. And I can see the answer. Okay, so maybe this wasn't quite tricky. So basically this whole thing has to be 8, but there's 2 of them, which means each square must be 4. And so the answer is 4. Siyabonga, too easy. Okay, let's see. I've got another one here. Should we just, I think this is going to be quite a bit harder, but since you guys are winning at life, we may not finish this one today because I'm only going to give 2 minutes, but see if you can get this one. Oh my goodness, I'm getting a headache just looking at it.
We like the challenge, teacher Peter.
Okay, you know what? I'm just going to give you a glimpse of this today. I'm not going to finish it, but this is going to take us a couple of sessions. So I'm just going to give you this to start thinking about. And all I want you to do is in the chat, if you notice anything that you think would be helpful, I just put it in the chat, because I don't think we're going to solve this today. But what we can do is solve a little bit over this lesson and the next. Okay, so what do we spot that might be helpful? Can see blocked by webcam, huh? Which of these equations do you think we might start with? I have this idea. Maybe we could take the top and we could use substitution, and we could replace the red one and the yellow one using stuff from down here. Maybe we could change it so all the colors are the same on the top line or something. Yeah, some of the caps are half full. Okay, right. So the good news, guys, is that I definitely have found a brain break that will keep us busy for a little bit of time. But if you want to take a screenshot of this brain break, take a screenshot now, and we'll come back to it in the next lesson. My suggestion is this. What? Notile thinks she's got it. Okay, we're not going to have time to discuss it in absolute detail, but Notila, I'd be very interested in what techniques you use. And so I'm going to ask everyone now to take a screenshot of this brain break. You did say you wanted something harder, but perhaps this is a little bit too hard. Maybe not. Take a screenshot, and then we'll have a little bit more time to chat about it. I think the way I would do it is I would try and replace some cups with things from other equations down below. That's what we were joking. This one is hard.
The course is apologizing. He's like, no, sir.
Okay, cool. Let's go back to the lesson. Okay, so just to show you, there are always harder brain breaks out there. So we were finishing this question, and I want to now go to some old exam questions. And so in this, I'm going to go over the 3A plus B, but those students who are feeling very comfortable, I want you to go ahead and try and do both. These are from old exams. You can see that straight away. For students who need a bit more structure, and I feel like maybe you've missed a lesson, we are going to go through in detail this one on the left. However, if you could do this quite quickly and you feel like, I don't need a detailed explanation, then what I want you to do is I want you to go off and do this. Okay. Now, we're probably going to do these two questions for the remaining time in the lesson, because these are all exam questions. So over to you guys. But for those students who would like a bit more structure or have a conversation around this, can you raise your hand? And I'd love to talk through you the method. So who would like to ask a question about this first one? What are you wanting to know specifically? So maybe raise your hand if you have that question. I know that if I was starting this question, I would start by checking what the second difference is. Okay. Is someone's hand up?
Yeah.
Whose hand is up? I can't. Maybe you could unmute them.
It's Candy.
Candy? You want to unmute Candy?
Hello, sir. Can you please explain a little bit about the quadratic pattern, because I only joined the class like today, so I missed the basics.
Okay. All right. So let's do step one. So step one, Candy, is to look at the pattern and find the first differences. If I go 5 minus 3, I get 2. If I go 8 minus 5, I get 3. If I go 12 minus 8, I get 4. Are you okay with working out first differences?
Yes, sir.
Okay. Now, the second step is to find the second difference. And the second difference we get by subtracting the first difference. And in a quadratic, we expect those to be constant. So 3 minus 2 is 1. 4 minus 3 is 1. Okay, so Candy, are you happy with that part? That's always the first part in a quadratic pattern.
Yes, I'm fine.
Okay, perfect. Now, here's the next part. We have 3 things that we look at. There is the 2a bit, there's the 3a plus b part, and then there's the a plus b plus c. Now, where these numbers come from, if you look at video number 2 in this lesson series, that will tell you why we're using these 2a, 3a plus b, a plus b plus c. What you really need to know is what is equal to 2a. And in our method, what is equal to 2a is the second difference. And so we would say 2a is equal to 1.
Okay.
Are you with me so far? Okay, now,
Yes, sir.
3a plus b. 3a plus b is equal to the first difference. So I'm going to the line for first differences, which is this line over here. What is the first difference, Candy?
2, sir.
Perfect. All right. Now, the last bit is what is a plus b plus c equal to? It's equal to the very first term in the pattern. So what is the very first term in this number pattern that I've given you?
It's 3.
Perfect. Okay. So if you've got this, all you need to do is solve a, b, and c now. So I want to ask you, if I just focus on 2a equals 1, what is a going to have to be equal to?
So it's going to be equal to a half.
Perfect. Because you just divided both sides by 2. Okay, now the second part is a little bit trickier because I have to sub in the value I got for a from before, but it's not terribly difficult. You go 3 times by whatever a is, plus b is 2. And I said above already that that's a half. So now I get, what do I get? 3 times a half, I get 1.5. So 1.5 plus b is 2. What do you think b is going to be?
I'm not sure.
Okay. So if you look at this at the moment, if you've got,
I
yeah,
think it should be equal to a half. If I'm not,
yeah, it would be a half. Exactly right. So somebody said they couldn't see the second question. I can try and make it a little bit bigger, but let's see if that's helping me. Okay, and then the last bit
I think they're talking about, sorry, I think they're talking about 6.1.
Oh, they can't see the T26.
They can't see the 6.1. So the question 6.
So what question 6.1 is asking is, what is the 26th term in the pattern? And so in order to get that 26th term, I'm first finding the equation of the quadratic pattern. Okay, so the last bit. Candy, I'm going to do this with you. I'm just going to say, look, I know that a is a half. I know b is a half. And then I go c equals 3. So then what does c have to be equal to?
so I already did this, and I found c will be equal to 2.
Perfect.
I substituted the half, and then I calculated and got the answer 2.
Yeah. Okay, now this is good news because I have a half n squared plus a half n plus 2 is the general term formula for this particular quadratic pattern. But I wanted to find the 26th term. So Candy, how do I find the 26th term?
So I'm going to substitute n by 26, and I'll solve it from there. So the first one, it's Tn is equal to 1 over 2. We substitute the n squared by 26 plus 1 over 2. We substitute 26 again plus 2.
Yeah, perfect. So I tell you what, I think you are totally smashing this. And so pop your answer for the chat. I'm going to use my calculator now just to make sure that we get the same answer. But I'm sure that we will. So
well done, Candy. That was well explained.
Well done. Yeah, you see, actually, okay, let's make sure that I get the right answer here. So I got 338, then plus 13 plus 2. 13 plus 2. I get 353.
53. Yes, I also got that.
Perfect. Awesome. Okay, and now for students who are working on question 2, I'm going to give you a little bit more time, but you should be, this is sort of this is about a 10-mark question, so we need to give you some time, but it seems to be going okay. The 4th term is 109 in this particular question 2. If you've got, well, the very first question is actually asking for the 5th term. And remember, we can actually use the first differences to help us. So ask yourself, how much did I go down by to get here? How much did I go down by to get here? And see if you can use that pattern to figure out the 5th term, which is the next term. So Loretta, I agree, the 4th term is 109, but what is the 5th term? So Bradley, I see, could you help us with 2.1? Do you want to raise your hand, Bradley, and we can unmute you to get the answer for 2.1? Will you help us out?
Bradley, where are you?
So we take away 51 there, and we take away 45 here. We take away 39 here. Now, what is the pattern going to get us to there? Well, it seems like it's taking away 6. Well, it would be taking away 33. I would get 76 for that term over there. But you could find, yeah, so for a lot of you, what you could do is you could work out the formula for the pattern first. But just to show you what I did, because it was first, I just looked at the pattern of the first differences. And if I looked at the pattern of the first differences, I knew that to get the next one, I would take away 33, because the second difference is basically 6. Right? So I was going up. Notice how, guys, I'm just doing the second difference and the first difference on top of each other, going up because of space. But you can do that if you have to. So I get, to start me off with, for this pattern, I've got my second difference is 6. Can you work out the general term formula? And that is what I want to give a little bit more time for. So what were those 3 steps? Can you still remember them? I went through them with Candy. but maybe it's worth writing them out one more time. 2a equals something. 3a plus b equals something. A plus b plus c equals something.
You guys are on fire.
So, I can't see all the camera feeds, but are students generally working hard now and engaged with the problem, I take it? That's the...
Yep, everyone is working hard, and on the comment, already given the answer.
Fantastic.
Well done, guys.
Okay, see, Bonga has some answers coming through. Let's keep those answers coming through in the chat because we want to compare and see there might be slight differences, or we might be all getting the same thing, which probably means we're on the right track. And what does 3a plus b have to be equal to? It's the first difference, which is minus 51, according to my little, admittedly a bit scruffy working up here. Let me just check that. 193 minus 244, yeah. So how am I going to work out what b is? Well, I'm going to go 3 and there should be plus. So basically, I get 9 plus b is minus 51. Now, how do I work with that to help me? I feel like the 9 is getting in the way of things. So I'm going to take away 9 from both sides. And if I do that, I should get b is minus 60. Now, what is my c going to be? Well, I go 3 minus 60. Oh, actually, let me do the working first. What does a plus b plus c have to be? It's the first term, which was 244. It's up here. Then I go, a is 3, b was minus 51. Sorry, b was minus 60. And c was this. So I basically have minus 57 plus c is 244. I can just move this down. Okay. And so I'm going to add 57 to both sides. And I get 57, let's say c. If I add 57 to both sides, I get 244 plus 57. I get 301. And so my general term formula should be Tn is 3n squared minus 60n plus 301. Okay. So I want to hear questions now. Where did the 244 come from? That is a great question. So let's go and find it. When we have a plus b plus c, which we always have as our third step, that will always be equal to the very first term in the quadratic pattern. And you'll notice that the very first term in the quadratic pattern is 244. So does that help, Anelia? Okay, now the last thing today that we want to do is we want to find out which term of the pattern will have a value of 308. And I'm not sure we're going to have complete time, but all we need to do is we need to basically sub in that 508 and make it equal. Basically, it's going to go into this wonderful formula that you've just figured out. It's going to go over here, and you're going to say the value is 508. Find n for me. So that would be step 1. Who would like to tell me what I do with this 508? Say I've had temporary amnesia and I've suddenly lost my years of training as a math teacher. What do I need to do in order to get this equation into the right form? B should be, send it to the other side, exactly. So if I do that, I get 3n squared minus 60n plus 301 minus 508. Okay. Now this is good news. Minus 508. Because I can simplify it further and I get 3n squared minus 60n, 301 minus 508. I get minus 207. And so now what I have to do is I have to solve this using the quadratic formula. And so if you remember from the earlier lesson, or it's looking a little bit like a graffiti wall, isn't it? But earlier in the lesson, I said to you the quadratic formula is just what I call delta. And so why don't you start by working out what n is? And then I want to see those answers coming through in the chat. I get delta as 6084, and I know I've done it correctly if I get a, yeah, okay. So my delta is that, but that's still not the answer I'm looking for. Can you use that value to help you get the answer? Because remember, delta is that thing there. So n is equal to minus b, and b was already a minus, so it's minus 60. I'm going to say plus the square root of that, and 2 times a, so this would be 2 times 3, or 6. Again, I'm ignoring the negative sign, guys, because I know I need a positive value, so I get 60 plus the square root of 6084 divided by 6, and I get 23. So T23 equals 508. Question is, why is it minus 4? So have a quick, Rachel, that's where you calculated delta, 6084. So when I calculate delta, what I do is I say b squared. So I went here and I found b. B was minus 60. So I squared b minus 4 times a. So here was a times c, and c was this value here. So I got 6,084 when I did that calculation. And the reason I do that is otherwise the quadratic formula can get very clumsy. So then I said, okay, cool. To get my answer now, I'm going to use this bit here, and I go minus b, sorry, plus the square root of that divided by 2 times 3. Okay. Cool. Guys, can you just give me a sense? I mean, I think we're pretty much ready to wrap up, but are there any final questions? If any students would like to ask any final questions or clarifying before we get to the quiz, now is a good time to raise your hand. Okay, did I change your 23 to a positive? I get a negative. Okay, here's the really important bit. When I use my quadratic pattern, if you look at the formula, it does have a plus and minus. But because I know I'm looking for a positive n value, I'm ignoring the negative and just going basically 60 plus the square root of this divided by 6. Okay. And so, I mean, it's not, you can sometimes, in some questions, if you, the positive and negative value, you do sometimes need to check the negative one. But in this case, because it was a positive number to start with, and yeah, basically I could tell by the context that I only needed to try one. And also because of time, I wasn't going to do both. However, in the test or exam, if you're unsure, just do both. And if the one is negative, ignore the negative. Okay. Cool. All right. If there are no more final comments or questions, then I'm going to ask you, Linda, to please put the quiz in the chat for those students who are comfortable. I wish you good luck. Enjoy the quiz. I'm sure you'll enjoy it. And for those who have questions, if you just stay on the line, I will try and help you as much as I can. Erin said the third question is a bit tricky. It is a bit, Erin. This is, I've literally got you now at proper exam level. These are old exam questions. What I want to suggest, Erin, is if you go and look at the recordings, if you watch me explain these on the recordings again, you'll see how the process becomes a bit more predictable. And so I'm going to recommend that for you, Erin. Because if you see a couple of examples like this, you start to realize, sub in, then solve, and go from there. Okay. All righty. So everyone is heading off to go and do their quizzes. Thanks, everyone. I hope that you got a lot out of this lesson and the course. I enjoyed teaching it, and I feel like, yeah, there's a good foundation of quadratic patterns for you guys to work with. Okay.
Yeah, it was a good one. Thank you, Teacher Peter.
Anele, 3a plus b. Anele, did I not answer your 3a plus b question? So the 3a plus b is always going to be equal to the first difference. Okay, always the first difference. If you want to know where it comes from, I refer you to lesson 2, where I spoke about kind of where these 3 facts that we always used. Okay.